In the activities you've done already, you've seen examples of direct variation, y equals kx, as well as inverse variation, y equals k over x. In both cases, k stands for the constant of variation, so it's a number, and x and y are allowed to be variables. Combined variation allows us to have what it says, a combination of direct and inverse variation. So something of the form y equals kw over x. Notice all of a sudden we have more than one input and one output. So combined variation is not a function with a single input and a single output. It's a more complex relationship dealing with multiple variables. Joint variation is also not really a function. We're not dealing with one input and one output. But the difference from combined variation is that although you might have multiple inputs, they all have to be in the setup of direct variation, so multiplication rather than division. We're going to focus mostly on direct and inverse variation, but joint and combined variation absolutely come up in word problems, especially we see a lot of formulas in science that involve these types of relationships, so it is important that we take a look at them here in algebra. Before we get into really doing problem 1, part A and part B, we need to realize something about direct and inverse variation and that k, the constant of variation. Let's imagine we take that inverse variation equation and we solve it for k, so we get k alone. Notice that says that the constant of variation would be equal to y divided by x. This becomes a test to see if something is a direct variation equation. If I test a set of data and every time I take y and divide it by x, I get a constant, the same value over and over and over again, then the situation is a direct variation situation. Let's think also about inverse variation. We start out with y equals k over x. Well, if I were to multiply both sides by x, that would solve for k, and I would see that k equals x times y. This is the test that we can use if we want to know if something is inverse variation. If we take all of the xy pairs and we multiply the numbers together, if we always get the same number, in other words, a constant value, then we have found the constant of inverse variation. So that's what we're being asked to apply in 1a and in 1b. We're asked, is the relationship between the variables a direct variation or an inverse variation or neither? Now, you really can just pick one to try, see if it works. If it does, great. If it doesn't, try the other one. Sometimes we can kind of think through which one might be more likely, and that helps, but there's not always a guarantee that it's going to work that way. Here's what I mean. Look at your x's, 1, 2, 5, 6. They're increasing. Look at your y's, 52, 34, 4, 2. That's decreasing. So the x's and the y's are going in the opposite direction. It's more likely that that's going to be an inverse relationship. So personally, I would start by testing for an inverse relationship. So I'm going to test for k by taking all the x times y's. Well, 1 times 52 is 52. 2 times 34 is 68. 5 times 4, oh wait, why am I even doing this? Are those the same? No, those are not equal. So I don't even need to test the rest of it. This is not an inverse relationship because I'm not getting the same value every time I check an xy. So I'm actually going to stop right there. Didn't need to go any further. Well, now I need to see if it's direct variation. Direct variation would say if I take all the y's and divide them by their x's, I should get the same number every time. So I take 52, I divide it by 1, I've still got 52. I take 34, I divide it by 2, I've got 17. Right away, they're not equal. So this is neither a direct variation nor an inverse variation. I'm not asked to figure out what it is. I'm not asked to find an equation. I'm just being asked to find out, is it direct variation? Is it inverse variation? Or is it neither of these things? Let's look at B. 0.2, 0.4, 0.51, those are increasing. 0.8, 0.4, 0.32, 0.16, those are decreasing. So again, my instinct tells me let's try for inverse. So I'm going to try to multiply the x's by the y's. When we do that, we see 0.2 times 0.8 is 0.16. 0.4 times 0.4 is also 0.16. So it's finally worth trying past the first two attempts. Well, half of 0.32 is 0.16, and 1 times 0.16 is 0.16. We found it. The constant variation for this inverse variation problem is that 0.16. So this one is an inverse variation.